Howdy everybody, welcome back to the Mega Man tutorial. So last time we set up our player object, putting in all of our camera setup, our enums, variables for animations, variables for movement, and our variables for our sprites. So today we're going to get started on making the player character playable. So let's get cracking. We are going to need to start adding states and stuff to our character. So let's open up the step event. And there's a lot of code in the step event, but I'm going to try to start us off with the most basic code here. Our state execution. So we need to reset our sprite preference because we have this manual sprite change variable that we're using to tell ourselves that we want to use a sprite other than what the sprite lookup table would normally use, if we ever need that, such as if we wanted to use a different sprite to do a custom animation. Then event user state, which will use the player state, so move state is 0, and event user would be user event 0. And of course, if not manual sprite change, then sprite index is equal to sprite state direction facing, and this will ensure that our state and our direction facing will be used properly for selecting the proper sprite. Direction facing actually doesn't really do very much because we aren't using it to check around what direction we're looking for the most part in this game. We're going to be using X scale for the most part. Alright, now that that's in there, let's see, what else can we do? We want another thing. Let's put this in. Pound region positional clamping. And in here we want to have a sprite half width. So figure out the half width of this of the player's current sprite, and then clamp our X to our current room's X and our room width. Actually, we would probably use current underscore room underscore dot X plus current underscore room underscore dot let's see, what is a width? Would be sprite width. Need the width of an object. Room width, sprite width, tile width. Well, we can do it like this. X. No, I don't know. Come over to the room boundary. So we've stretched this all the way across the screen over to here. We want to make sure that we can't go off this side over here. Oh, wait. No, that would be completely wrong. The reason why we kept this at room width instead of the width of the object here is because we can go off the edge of a defined room to the right. because if we go over to the right, then that'll get us to the next room, which is right here. Go over to the right, and that'll get us to the next room, which is right here. You can't go to the left, though. So, there we go. That's actually completely right, and my entire attempt to find the width of an object that I've stretched across the screen is completely wrong. As usual. Alright, so we set our X clamp to current room.x, so we don't want to go past the left, plus our sprite half width, room width minus our sprite half width. And that'll keep us from going off the screen when we don't want to. And another little thing we want to set up here are timers. If iframe timer does not equal -1, then iframe timer is equal to approach, my iframe timer to -1. And if iframe timer is equal to 0, then iframes is equal to false. So this is just resetting our iframes, exactly like we did in the Chip and Dale tutorial. So let's close these regions since we don't need them open anymore, hopefully. Let's see, I also have pickups. We won't be doing that yet. We also have death. We have damage. Oh, this is actually fairly important here. So this is a big change from the previous tutorial with the Chip and Dale tutorial. In the previous Chip and Dale tutorial, I did a bunch of stuff, checks for if you're on the ground in the begin step. But checking for those in the begin step risks your character, risks having, so if we come back to our objects, our game objects, our object input, you'll remember that we execute our input object in the begin step and we get all of our input information there. So if we were to be checking if our player character is on the ground in the begin step, we risk missing a movement to the right or the left or something like that that would be inputted after the because the input object could execute before or after, because we're not controlling for that, we could end up getting an extra frame out of a position of where we expect to be. So to combat that, instead of doing all of our position checks in the begin step, we do them in the step event. That way we get all of our input properly. Let's see. Transition check, we'll bother with that later. Pausing. Okay, so we're just going to jump over to our ground check and our direction check. So let's grab that code here and pop this open here. So we set up a couple of local variables for positions that we want to check. So position 1 through 7. We want a tilemap underscore get underscore add pickle tick tilemap. So we're getting whatever is right here at the in the tilemap in the collisions tilemap. B box left, so the left side of our character, and B box bottom, so down there at the bottom, and B box left and bottom +1. So that would be a check to see if we're in air and if we are on something solid, so greater than or equal to 1. This allows us to check to see if we're on ground, if we're on a platform, or if we are just because if we were rising through platform, we don't want to accidentally think that we're on the ground or something at that point. And you do the same thing on the right, to check on our right, so we can be on the edge of a platform on our left, or we can be on the edge of a platform on our right. A collision line here for objects. Parent solid. We need to go, actually real quick here. We need to come over here, add a group, call it parent objects. Create an object, parent underscore solid, and give it a parent sprite solid. That's all it needs. That will be our parent solid if we're going to set any object to be solid. We don't really use any solid objects in the Mega Man tutorial though. At least I don't think we do. So we could probably remove this completely, no need for it, but we're leaving it in there in case we want to have object collisions. Then we have timeout get a pixel, bbox left plus, bbox right minus bbox left times 0.5. So this is our right and our left, so that gets us the width of our sprite, or well, not the width of our sprite, it gets us the width of our hitbox specifically, and gets us the half width of that, and adds that to our left position, and checks at the bottom again. So that would be our bbox left, which is closer to right there, plus the bbox left minus bbox right. So right is at 32 and left would be at 16, so that would give us a value of 16, so that'd be 8. So our left position plus 8, so that's actually slightly inside right there on our character. And why was I checking for that there? P6 is equal to 0 and P7 is equal to 3. Oh yeah, that's checking to see if we can collide with a ladder. So we want to have a little tiny strip right here in the middle of Mega Man that says, oh, we are colliding with a ladder. So alright, then we have this overly complex on-ground check here, and these are all checking for Boolean values to make sure that everything checks out. So we have if we're on the ground on our left, and if we're not inside of a solid object and we are on the ground, then we are on the ground. Or if we are not inside of a solid object, e.g. a platform, and we are on the ground with P4 on our right, then we are on the ground. Or if underscore P5, if equal to, it does not equal no one, so if there's a object below us, then we are on the ground as well. Or if we are, if P2 or P4 are equal to 1, or if underscore P6 is equal to 0 and P7 is equal to 3, e.g. a ladder. And Y speed also has to be 0. That way, that is part of the check for making sure that we are not rising up through a platform. Alright. A lot of stuff going into ground checking there. And we also have our direction, X underscore input and Y underscore input. Object input right, left, down, and up, being subtracted from each other to find out which direction we're inputting. Input direction is equal to a point direction, so if we have a grid and our 0, 0 point here in the center of the grid, X input is, that's equal to 1, then you'd have a value, you'd be over there. And if Y was equal to 1, then we'd be kind of at a 45-degree angle position right there. We can't actually input X1 and Y1 at the same time due to the way a four-direction pad actually works. So X input and Y input. If our X input does not equal 0, we're not caring about our Y input because the Y input doesn't make any difference in how Mega Man's direction changes in the game. Direction facing is equal to our input direction divided by 90. So if we have x is 1 and y is equal to 0, then we'd have a 0. That would give us 0, which according to our macro script, we have dir4, that is equal to right. And if we have -1, which would be left, then that would be 180 degrees, which would give us 2, which is left. And if direction equal facing is equal to 4, then direction underscore facing is equal to 0. So if for some reason we come up with 360, we just treat that as a right. Alright, so that's everything inside of there. So let's go over to our movement state. We're at 15 minutes here. Let's see if we can get basic movement into here. So we're going to need a pound region states. We aren't going to put anything in there yet. But when we add extra states, we'll use it as a way to change between those extra states. Pound region. Well, the other ones we'll just copy out. Acceleration. So if our x input does not equal 0, then x underscore speed is equal to approach our x speed to our max speed times the sign of the x input. So if we're pressing left, our input will be -1, so it will give us a max speed. If we come back to our movement variables, our max speed is 1.5, and we'll move towards 1.5 at accel. So our acceleration is 0.5, so every frame will increase our speed by 0.5. The reason why we're not actually going directly to 1.5 is because Mega Man actually has a slight acceleration curve to when you change direction. So you have to accelerate through steps of his speed in order to reach the maximum speed. And of course, if our x input is equal to 0, then we approach 0 by friction. So apply gravity, y underscore speed underscore is equal to approach y speed towards fall speed by gravity. Gravity is 0.25, fall speed is 8. 8 frames per second is the fastest you can fall through in the game, I believe, at least from my pixel by pixel checking. Then we have, of course, that skidding I mentioned. If our x input does not equal 0 and our speed is still less than my max speed, then we need to make our image speed equal to 0, change our sprite index to sprite Mega Man skid, and set manual sprite change to true. So don't animate, and make sure that we are using the skid animation. Mega Man is just sort of slightly skidding forward in that animation. So that's our acceleration. Speed fractions. These are again directly from our Chip and Dale tutorial. If we're on the ground, get rid of our speed fractions. Otherwise, add our fractions back in and store and remove fractions for the next frame, so that we're always moving by integer values. In NES games, there are no sub-pixel movements that I know of. So we store our sub-pixel movement because our max speed is 1.5. So that means that on our first frame, so if we're at maximum speed, our first frame will move 1 pixel, and the next frame will move 2 pixels. So it'll just move back and forth between 1 and 2 pixels each frame, and that'll give us 1.5 speed. The excess pixel isn't visible when you're playing the game. Same thing with the y speeds. So our x fraction is equal to x speed. So if we're at 1.5 minus the floor of the absolute value of our speed. So absolute value of speed would be if it's either 1.5 or negative 1.5, it'll just be 1.5. So 1.5 floored, so 1.5 becomes 1. 1 times the sine of x underscore speed. Again, if we're going to the right, to be 1. So that just comes out as 1. So x speed minus 1. That gives us a x fraction of 0.5. And we subtract the x fraction to 0.5 from our current speed, which we have accelerated to over here. And same calculation for the y. Alright, next up, collisions and movements. Update speed, post-collision detection, so that anything that needs speed information will be kept up to date. So first off, we do our solid collisions with our objects. Then we do collisions with our tile map. As far as it goes, again, I'll go over these object scripts briefly, and these movement scripts, I'll go over them more in detail when we get to the latter state, because that's when we'll actually do some updates to the script, if you aren't using the scripts that I provide. Then last but not least, we have the animation region. And you'll note that I made some slight changes in organization and how we set stuff up here. The main reason why I made these changes was because, well, let's make sure I actually did it here. Yeah, no, I didn't do it right here. So in the future, animations will be moved up here to before collisions and movements, because with what I currently have here, the sprite index will be changing after we do our movement and collision detection. So by doing that afterwards, we run the risk of having our animation change in such a way that we end up with doing a calculation of our sprite, so that if the let me open up a sprite here. So if the collision mask changes very slightly, like by 1 pixel between this animation and say this animation, then we can end up being inside of a tile at that point. Luckily, nothing that we do here. These all use the same size and positioned collision mask, as you can see right here. And the origin is right there on both of them. So it doesn't matter in this case. But if we were to be changing our animation in such a way that it could cause a tile break like that, then we need to make sure that we do the animation before we actually do our collision detection. So image speed is equal to animation speed. If you remember, we set our image speed to 0 back over here in animations. When we start, set our speed to our whatever our animation speed is. Skidding if our x input is equal to 0 and x underscore speed does not equal 0. Again, checking to make sure our skidding is actually happening. I actually probably just duplicated this right here and forgot that I had copied it over to here and then didn't erase the code from here. So you could probably just delete that bit right there. But when we're idle, so if our x speed is equal to 0, then set our image speed equal to 0, set manual sprite change equal to true, and set our sprite index equal to Mega Man idle, because we don't have an idle state, so we're not actually changing our sprite at that point. Then we have animation timer, a very old friend variable. If it does not equal 1, then we want to approach it to -1. And if it is equal to -1, we set animation timer equal to second times of 1.5. So once it actually reaches -1, reset us. And if animation underscore timer is equal to 0 and not blink, then set blink equal to true. Animation timer is equal to sec times 0.15. And image index is equal to 1. What are we doing here? Mega Man has a blinking frame where he blinks his eyes for 0.15 seconds. So we need to set this up so that every once we actually get to 0 and it's not blink, then set blink to true, and animation timer equal to 0.15 and image index equal to 1. And if blink is equal to true, then set blink equal to false, and then next time we come through we'll hit -1 and we'll reset the timer. If blink is equal to false, make sure our image index is equal to 0. And if we are not idling, then set my image X scale equal to the sign of our speed, our animation timer equal to -1, and blink equal false. Just reset our animation here. Alright, that should be everything. So let's actually check and see what we got going here. See if we can hit any bugs. There we go. Current room. We haven't set up our current room. There it is. So we're not actually checking for current room. Let me find that. Ah, yes, that'd be over in the step event. We're going to have a transition check. So part of that check is checking to make sure, checking to see what room we're in. So we create a temporary list, a collision list here. If our current room is equal to no one, then just set it equal to whatever room we're currently in. And then make sure we destroy the list because we don't need it anymore. The reason why we're using the list is in the hypothetical situation that you hit a corner in a large room where you could go either left, right, up, or down, or something like that, then you would end up going to the right first, and then you'd end up going down, and it kind of supposed to work like that, but I've never really tested it, so it probably doesn't work properly doing it that way. Anyways. There's an else if that would go into here, but we're not actually going to put it in yet until we actually do room transitions. And players there. Invisible. Real quick here, so come back to your, let's see, music manager, and instead of going to room copyright, just go to room_wood_man stage. That way we don't have to bother going through the main menu and everything. We'll just go directly to the room. So why is he invisible? Because he has a draw event, but we haven't actually put any code into there. So We'll have to put the code into there eventually. But for now, we're going to end up this episode because we have reached almost 30 minutes. Far too long. So before we go, I'd like to thank Patreon sponsors. So let's pop open this. We have our good old Fragile Hearts, Crew Patreon, Damien, Kenneth Klein, John Dickey, and new Vladimir Soldatov. I can't remember the name. Nope. I don't have a way to reset that room directly, so I'll try to say your name more properly next time. Thank you, everybody, for joining us, and thank you, Patreon sponsors, for your support. And remember, good luck with your programming.